Baby, can you hear me?
Yes, can Prof. Very loud and clear. Okay, Prof. Good afternoon. So we will start the session, yeah? Okay, Prof. So good afternoon to everyone who are joining us today. Okay, welcome again to all of our school students, our teachers, and parents from all over Malaysia. Not forgetting those who are joining us from Sabah itself, from University of Malaysia Sabah, to all the staff and students. Thank you again for being present to our session today. Okay. For our STEM speaker series, for those who have joined us for the first time today, we will just give you a brief introduction of what this program is about. So this STEM speaker series, which in short for science, technology, engineering, and also mathematics, is a co-joint effort between the Faculty of Engineering in University Malaysia Sabah and also U Science University Malaysia Sabah. It is aimed to deliver a unique and interesting STEM topics which are designed from our subject matter experts, especially our academicians, to increase the interest of school students, teachers, and also our community alike to venture into the fields of STEM. So for any questions from our audience today, so please feel free to drop your question in the chat box on the right-hand side of this YouTube live session. So we can read it out for our lecturer or our expert today, and they will give their opinions on your questions later on. And also, please be informed for today's session, e-certificates will be given to all school students and also community and also our teachers. But you must fill in the form through a QR code, which we will share with you at the end of the program today. And so please stay tuned with our program, yeah, until the end of the program. So, as an introduction of our speaker today, with us is a very distinguished academician and also researcher from Faculty of Engineering, University Malaysia Sabah, Associate Professor Insinyur Dr. Muralindran Mariappan. He is actually a very professional engineer with a master lead trainer and expert consultant for minimalist educational robotics and application, whereby he have been awarded the 2020 World Book of Record in United Kingdom for organizing an online international coding competition. And also in 2015, he is also acknowledged by the International Invention of the Year with a Platinum Award at the British Invention Show in London, United Kingdom. Besides that, our speaker today is also a consultant for education, industry, and also research in medical robotics, in intelligent systems, in educational robotics, and also in machine intelligence. Okay, and he is also the head of the Robotics and Intelligent Systems of University Malaysia Sabah, UMS. Besides that, he is also the cluster head of the Physical Computing for Digital Maker Hub in Sabah. And he has written over more than 140 technical publications with 9 patent or copyrights. Okay, and he has supervised more than 30 postgraduate students, including 16 PhDs and also 16 master's candidates. So he has also obtained research grants of more than 1.6 million ringgit from the government itself and also external sources. And he has also won 41 medals for research and innovation in local and also in international levels. So today, without further ado, please welcome Prof. Dr. Murali with his topic for today, Robotics Engineering. Please be invited, Prof.
Thank you very much for the introduction. So, welcome everyone. So today it is my pleasure to address you all and to share with you all my experience and also some insights that will create a lot of enthusiasm and interest for all of us to get to know and be part of the science community and also to be part of the community of science in the future, so that our ambition to achieve a very highly technological country can be successfully visualized. So I would like to share my slides. Okay? Okay, so we will start with this sharing. So you can see, so today we're going to talk about robotics engineering. So when you listen to about robot is not a thing that you just see in one place. Robot is a field. What we call in science is like from sea to space. Okay, you can have robot in the deep of the ocean, and you can have robot in the outer space. Okay, so the technology aspect of robotics is not only in one area, but it spans in all the areas. Anything you talk about, you can involve robots. Okay, so that is why we should really understand that a lot of things can be done by a robot. And then, you know, lately we talk a lot about industrial revolution, IR 4.0 and all these things, you know. If you look at the history, you know, in 1780, we went into industrial revolution 1.0, where you use machines. Then when we went to 2.0, we use electricity. 3.0, we use a lot of automation. Electronics came in, electronics and computers. Then 3.5, we talk about globalization. And then now we are talking about 4.0, we are talking about digitalization, where we use a lot of data from everywhere. We use artificial intelligence to automate things and take a lot of data and process. But you must understand, we are also looking into another step, 5.0, which is personalization. Why I want to emphasize this is because when you talk about robotic technology, you must understand that robots not only work alone. Those days, yes, robot used to work alone in the factory and do everything. But when it comes to personalization, the aspect of collaboration is very important. That means robot will work together with human beings. So this is what emphasized in the industry 5.0. This is for our information. So today we're going to talk about overview of robots. I'm going to tell you about a little bit of history of robots, because no point talking about robots when we don't know anything about the history, you know, where it started, how it came. And then we're also going to talk about the fundamentals of robots, how they classify robots, what type of robots exist, and where we use robots. Some ideas, no? Then for us, actually, whether you are primary school, secondary school, university, or parents, how actually you're going to see what are the things that we really need to embrace so that we are not left out in the future. Imagine if we in the older generation think that handphone is not necessary. Imagine, if we just think handphone is not necessary, only is necessary for the kids. So what will happen to us? We will be deprived of technology. We cannot communicate with the younger generation, and we will be in dilemma, right? Same thing. The technology is not only for younger generation. The technology is also for the parents, for the elder generation. So we need to embrace all of this and get to know things so that we are not just fixed to one job scope that is available now. We have to look very far ahead in the future. Okay? So let's look into the history of robots. How it started. The first one is in 1921. The word robot itself was made from a play. From a play. So the play, the robot means subservient labor. So they have created a robot that works like a human being, forced labor. So this was how actually electromechanical robot was used in a play. You see, that is since 1921. Then in 1940, this is where it started. The first robot, two first robots was created by electrical motor. The robot name is Electra. It can dance, it can count, and can smoke, And then the best part is the robot has a friend, a dog, companion. His name is Paco. It can stand on hind legs and it can bark. It can walk. See? Like a real dog, So this is how it all started. And then in 1941, very important, Isaac Asimov, he used the word robotics to describe the technology. This is where it started. Okay? So in 1941. So in 1961, okay, after so many years, then only they produced the industrial robot, mass production. But it was there in 1954, okay, already patent. But mass production of industrial robot, this is the one. Its name is Unimate. Okay, it was the first one built using hydraulic, So it was created for factory automation to be used in factory. So to make cars, welding process, and all these things. Okay. So this is the demonstration. They are showing this demonstration in 1966 in a TV show. Okay, and then they also use it in a display in a hotel in Los Angeles in 1967. So this is history. And then what happened in 1968? They created the first mobile robot with vision capacity. Vision capacity means what? That means the robot can actually see. His name is Chicky. Okay, it has a television camera, range finder. It can know how far it is, sensor, So it could go and see if there's an obstacle. It can decide and respond. So this was the first mobile robot. Okay. Then what happened? Same time in 1968, we have this General Electric walking truck. Okay, so imagine a truck that can walk. So that was, but it's manual control. Manual control. In 1969, we have this first electrically powered computer control robot. Okay, so this is the first electrical power, and this was used as a standard for all the projects. Okay, we call it the Stanford robot or Stanford arm. Okay, and in 1974, the same professor, he marketed this version of robot for the industry application. The company was known as Silver Arm. Okay, so as we all know that you have seen robots in TVs and everywhere, right? So these are the aspirations of robots there. In the movies, we can see from Robocop, where they connect this person's brain to a robot, like a cyborg, Terminator, fully robot. Then you have iRobot, Transformer, Knight Rider as a car, Real Steel, how you imitate and the robot exactly moves. Stealth, which is a robot aeroplane. Iron Man, you all know that. Chippy, see? So these are actually movies that actually shows us how the technology can be so advanced and can be part of human life in the future. Okay? And then, so let's go into the next part, fundamentals of robotics. Because when we want to understand robots, we need to know what is it? What is it all about? So how we classify robots? First, one we call it a tele-robot. Telephone. Tele means it's a remote control. Okay. So this robot is controlled by an operator, but it can go very far, like a remote control car, remote control aeroplane. Okay. So it can work. They will call tele-robot. But we have another one called telepresence robot. What's the difference? Almost the same, but the person who's driving the robot or controlling the robot, he can see what actually the robot can see. He can control everything as though he is there. Like you have your clone somewhere, and then whenever you do something, that one also doing the same thing. So I can operate my robot from somewhere else. And we have such robots where people use it in hospitals, where this specialists from different part of the world can control a robot and go and see a patient in different countries. And they can talk to the patient. The TV will show the face, and the doctor can move the robot and talk to the patient, get some information, and feel very close, as though the doctor was really, really there. This is something that's very interesting. And then we have a static robot. Static robot is what we know that it's an industry, where they make cars, assembly, and everything. That is static robot. And then we have mobile robot. Robot can move. Okay, robot can move in the ground, or anywhere. There's a motion. It can decide the movement on its own. Okay, without human beings' intervention. Okay. Autonomous is that the robot actually can move without intervention and also can get power from the environment. So this is something that is very, very interesting. We have a lawn mower, we have a vacuum cleaner robot, we have a soccer robot, we have an insect robot. And then we also have aerial. Can you see that this aerial robot? So small. This is your palm. And this robot is so tiny. And this is a big one, like an aeroplane. But it's a robot. And then this one is actually underwater robot. So this robot swims underwater. And this is actually a robot in outer space. This is used in Mars. Okay. So this is beyond land, either flying or underwater or in the space. Okay. And then we have something else we call Android. Android is a robot like human being. Like human being, but they're not human being. Like this one. It's the first one is Asimo. Very advanced robot. Asimo can walk, can climb, can run, can kick ball, can jump in one leg, can talk to people, can shake hands. It's very, very intelligent in terms of control. Okay. And then we have another one, Sophia, intelligent here. It can see, it can give you a facial response like a human being and can communicate like a human being. That's very interesting. And then the other one, this one is, I put here because this is a robot that many use for educational purpose. They buy this robot for research and education to program it, to behave in the way that you want it to be. Okay, so this is some robot that we call Android. Android. And then another interesting part is that cooking robot. In MIT, in MIT in US, these engineers, they have created robots that can cook. So you go to a restaurant, you just sit in the restaurant and make booking. Okay, you book using your tab like that, what dish you want. So you set, and then all the items will be there already. It will be put into the robot, and the robot will start to cook. Okay, will start to cook, and then it will serve you. Okay, there will be only one chef to make sure everything is okay. Maybe put some garnishing on top and make sure everything is okay. One person only works. Others all the cooking all done by robot. So you can cook for many people, many different dishes, okay, run by robot. So it's called a spice restaurant, cooking robot. And then we also have, this is an example, we also have a pizza making robot. This robot can make 300 pizzas 12-inch size. 12 inches, this big, one long ruler. In hour, 300 pizza in 1 hour. Imagine how fast it can make, right? All by itself. You just put the material, the pizza will come up in 1 hour, 300. This is a robot making. Okay, so very interesting, huh? And then we have military robots. Robot like soldier, robot that can fly, robot like a bull to carry the heavy loads of the soldiers. And then we have medical robots. Okay, robot can do operation. Robot can go and clean the environment because like now COVID is there. We need to sanitize the place. So this robot will go to the place, the room, and then nobody will be there. It will on these ultraviolet rays, and then it will clean the whole room, kill all the bacteria and the virus. And then everybody can use. No need to go ask somebody to go and manually clean because you miss a spot. But robots will do everything like that. We won't miss a spot. And then also sometimes you're feeling very lonely. You need a fan, like small children need fan. They have pet robots. Real, like a pet, but it's a robot. So you can play with it. It will react with you. It will respond with you. Okay? So these are the things that is very interesting. The next one is that this is an entertainment robot. You know roller coaster? If you have been to roller coaster, this is actually a robotic roller coaster. The robot will take you around. Move very fast. This robot can move very fast. And also this one you can find in Dubai, in the Mall of Emirates. And then in Germany, they have a biological cybernetic robot, which they use it for research. Okay? The robot can do a lot of things, can make you move this direction, that direction, for research purpose. And we also have robots for the cinema. So Warner Brothers, they take the movie Gravity, like people falling in the outer space, but actually a robot is holding them. But in the movie, it looks like a person is there, but actually robot is doing everything. Okay? So a lot of robots is being applied in cinematography also. Like robot is flying here and there, taking videos, 3D videos, and then they combine. They do a lot of things. So this is how we classify robots. So you can see, robot is used everywhere. Very, very unlimited, you call it. So now, where is robot used in industry? So we talk about industrial robots. Why? Because robot applications started in industry. Most of the application nowadays in our country, basically, it is from the industry. Okay? I want to show you this statistics, this graph, because I want to show you that the amount of robot that people install, you see the amount of robot, how many units, 140,000 units of robot was installed in 1 year, in many, many countries. Okay? So robot is used very widely. And you can see the density of robot in industry. So Singapore has the highest density. That means that how many robots per how many people? Okay? But if your population is very high, then you will be having very little robot, like China, you see. Density is very low, although robot is a lot, but the population is very high. Okay? So you see, in manufacturing industry, the average is 113 robots per person, per 100,000 employees. So this shows that we are actually using a lot of robots for industry, manufacturing. Okay? And this is how robots of the industries are. So we can see that this is an articulated robot, we call it, the robot arm. And then this is a linear robot, like, your printing robot, like that. This is another type of robot, we call it the SCARA, selective compliant assembly robotic arm. This is a gantry robot, this is a cylindrical robot, because the movement like cylinder. These are like a spider, we call it the parallel robot. Okay? All these robots are used in industry. Okay? So, and then another one we have is a collaborative robot. Collaborative robot is very, very important because collaborative robots can work with human beings side by side. If you go to a normal factory, they have a robot in a cage. because the robot is very fast and very dangerous. It can hit you, it can harm you. Accidents can happen. So they put the robot in a cage, closed area. Okay, so when the robot is operating, they just don't go near. But collaborative robot is the robot can work with human beings, side by side, so that you can move the robot and let the robot do certain work. You also do certain work together. Okay, and then also you have some robots for transfer the materials. Take here and put here. You can use drones to transfer materials in the factory, right? And some robots are delivering products in the factory, outside the factory, okay? So all these things we call it the material transfer robot, or we call it the automated guided vehicles, or we call it drones also, okay? So, and then these are the applications of robot. So we have material handling, where we use robots for material handling. And then we also use robots for processing, welding, or spraying, cutting. Material handling is like robot will pick and place, okay? Or loading or unloading. The third one is we use for assembly. Assembly means fixing screw, nuts, changing and putting together. All these things are we call assembly. And then we also use robots for quality control, especially for inspection and testing. Okay? So these are the main areas robots use. Of course, got other areas, but these are the main areas that I would like to share with you, because the most of the application of the robot will actually reduce the cost for the industry. You see, if in industry, you can say that maybe almost 2/3 of the cost of the product is in material transfer. We're bringing one material from one place to another place, and then from one machine to another machine during manufacturing, and also sending it to you. So all these things are very high cost. But we can reduce the cost if we use robots, okay, to do certain tasks. Okay? So this is example of industrial 4.0 application of robots, where the robot can be used in all areas, because robot not only things that can move, but it's also the technology that we use. Okay. So now we go to the next one. We will see into the trending. Because people always ask, okay, we are talking about robots. Everybody is talking about robots. And many people know about robots. What is going to happen in the near future? Where is the market? What actually we really need to be alert? These are some things that we found it's very, very necessary in the future. Number one is delivery robots. You know, now COVID, right? Where you all buy, you don't go to the shop. Tomorrow you can get, oh, this mall got a close contact of COVID, so you cannot go to the mall. You cannot go to the shop. So you all of us, we are buying things online. Now, to buy things online, you need to deliver things, right? So in some places, they are using delivery robots. So you can deliver through the ground, you can deliver through the air, okay? Like giving a life buoy, this one. If somebody is drowning and the ship is very far away, by the time the ship reaches the person already drowned. So you just use a drone to send a buoy to the person. The drone can fly very fast, like an aeroplane, fly very fast, and then detect where the person, go to that person, very near to the person, and give it to him. Faster than an helicopter. No? See? You can deploy it from anywhere, so you can save lives. Okay, and then also in the hospital, you want to give medicine to the COVID patient. You want to give document. You want to give some transfer materials from one department to a different department in a very highly hazardous place like COVID. So what we do is we use robots. Okay? So this is called delivery robot. So you can see here all the sidewalk delivery robots. These are all the sidewalk deliveries. I mean, it go outside the house to give it to you. And then some robots are also there for on the road. We got a delivery van. I mean, the vehicle actually moves without a driver. The vehicle travels without drivers. The big trucks also, they have driverless trucks. It has all the sensors, no driver. It can be monitored by a person in the control room. They can stop, they can see emergency, they can decide a lot of things like a real driver. But there's no driver in there. So people won't get tired and they can keep monitoring properly. Right? Because to drive 10 hours, 12 hours, 15 hours, 20 hours, it's very tiring. But if a robot can drive, the person just need to monitor and you can just change the shift like that. Right? So delivery robot is one very important aspect. They estimate that it's $1 billion market by 2030. The second one is, we call it a swarm robot. Swarm means it works together. It's not only one robot, but multiple robots. Like you see, this the first picture. These are small robots, can move individually, but if the robot wants to cross this big hurdle, the robot will all join together and become like a starfish. And then the robot will cross. And then once it crosses, it becomes individual again. You can see now here, in the forest, they put drones to identify, to locate people. Maybe people are lost, somebody's missing, somebody got hurt, or they want to see anybody illegal, illegal, activities in the forest. So they can use drones. No? And you can see, for show, for show. You can see an aeroplane here. This is not an aeroplane. This is actually a drone. See, all these drones are flying. And all these drones can be programmed to create like an aeroplane, three-dimensional aeroplane. And you can move together like an aeroplane flying. You can change color, change light, and can do anything in the sky. So this is a very fantastic, area to explore. It's very, very interesting area to explore. Okay? And the third one is medical robots. Very important because technology now is becoming very advanced. We have this radiation surgery. We give radiation to a person to do surgery. No need to cut. Just send a signal, a laser like that. Particle therapy or like a laser. But it has to be done by a robot because it's very high precision. Okay? So these are the things. And another one is that in medical robot is like, it's very tiny. People put a pill. You swallow the pill. So the pill has a camera to detect, to take an image of your intestine. Or the pill, it goes to your stomach, and then only it delivers the medicine. Okay? Or the pill go into the blood vessel, and then it opens up. So your blood vessel becomes bigger, so there's no blood clot. A lot of things, this technology is there. And then the thing that the tools that the doctors use to do operation is so small, like it's like a small coin only. So you don't need to cut a big part of your body to do operation. Just put one tiny hole. Those days when I did my appendix operation, I cut this long, 6 stitches. I need to be warded for at least 1 week. They put 6 stitches. Then after that, I need to take out the stitch. It takes a long time to heal. Now, you just put one hole in the body, remove the appendix, and then you can go back home with it. Like almost nothing. It's like you're putting the COVID jab. Okay, so these are the things. And you see the technology now is called the nano technology also. It's very small. So the nanotechnology is doing a lot of work in all the parts of the body. Okay, so these are the things that nanotechnologies can do to human beings. From cell repair, cancer treatment, bone repair, controlling the arm and limb, people who paralyzed, medical records, you can keep data in your body. Okay? So these are the things that the next one is, like what I mentioned just now, collaborative robot. I'm showing you this because you can see this red color. This red color is becoming bigger year by year, right? Because this is the application of collaborative robot in the world. The collaborative robot is increasing now in the world. So this is the example of collaborative robot. The robot works side by side with human beings together. Because the robot can carry things, can be more accurate, but we can customize. You see, we can think and we can be very creative. But robot has the strength and also precision, right? See. So you can use by demonstration and the robot will continue to do and then the speed you can control, you can give power and then stop, So it's very interesting when you work with robots. So this is the future. So people say, oh, when robots come to the world, I will lose my job. No, you will work with robots. So you must know something about robots so that you can work with robots, right? So the world is now changing. At one time, you work alone in the factory. Then the robot work alone in the factory, and people have fear. Now, in the future, coming soon, robot work with human being. So you need human, you need robot. So as a person, if I am STEM educated, no matter what job I take, I will be very alert and aware of the technology, and I can use the technology wherever I want. Okay? So what can we do? People ask. 21st century, right? How actually parents, students, society can embrace robotics? First is, I need to know. I need to have a basic understanding of robots. I need to know robots components, about some safety of robots, some standards, how robot is being designed, where you can use applications, repair, maintenance. So these are the basic understanding that is required for robots. Second thing that I need to do is that how actually I can program robots. Because programming industrial robot is different, programming automation system is different, programming mobile robot is different. You can have an unmanned aerial vehicle, flying one, unmanned ground vehicle, unmanned underwater vehicle, unmanned marine vehicle, unmanned space vehicle. If I'm good in mobile robots, I can do programming, I can work anywhere in the world. Because anywhere there's robots, they need people who know how to program. Okay? Before you know how to program, it's good for you to know a little bit about the basic understanding of robots. Now then you want to go one step ahead, you must know how actually you can make the robot. Like you must know how the sensor works, okay, how actually the module is connected to the sensor. Because you're doing programming, right? It's just not software, but hardware is involved, no? And then how you can connect the robot to other machines, other assembly systems, automation system, other technology systems. So I must know. So that is interfacing part. These are the things that we need to have understanding. Fourth one is integrating part. I already have a robot. Now I want to integrate with human beings, number one. How am I going to make this interfacing? How a robot actually can talk to a human being, communicate with a human being. Well, the robot can understand you better. Okay? Then how am I going to use AI, artificial intelligence, a lot of data in the world, big data they call it. Every sensor giving one data. How am I going to take the data and use the data, put it into artificial intelligence, and then I use in my robot to communicate with all the machines and robots. So that's why we call interactive, because the data is very important for a person to know about the robot and also the environment. So these are the things that I have in mind to share with all of you, so that in the future, it is not about a specific job. Example, I want to work in the supermarket. Example, I work in the supermarket. But the supermarket will be so high-tech that the robot will go and take the things in the supermarket, put in the basket and send it back to you because you need to courier. No? So if I want to work in a supermarket also, I need to be very, have a basic understanding about robots. Then I can collaborate and work with robots in many, many areas, in hospitals, supermarkets, any other, in military also, in the police, in the bomba, everywhere we're going to use robots. Because the technology is such and it's in demand. Okay? So for us to prepare, we need to know. Like nowadays, you have washing machine, which is very smart. You put the clothes, it knows what's the weight, it will put its own soap and wash for you, and spin for you, dry for you, and give it to you. Okay? And then you have a fridge nowadays, very smart. If you put the egg there, the fridge can know how many egg is left. It will connect to the internet, order eggs for you. You can go to the shop to collect it, or they will send it to your house. So you just take and put back. So the fridge will know what vegetable is missing, what egg is missing, what is not there. So you can program it like that. So the intelligence is always there. So the smart house, smart facilities, smart car. Okay. So all these things are robots. So I must have basic understanding. I must know a little bit about programming. If you want to become very technical, then interfacing and integrating. Okay. So to have that understanding of STEM, science and technology, engineering and mathematics, is a very, very important factor in the coming future. So with that, I will hand over to the Secretariat, okay? Science. So with that, I end my talk. So if you have any questions, you can ask me.
Thank you very much, Prof. It was a very interesting and wonderful topic indeed, and very well presented, as it is very relevant to our current preparation towards the future, yeah, Prof. So we have identified a few questions from the audience, Prof. Maybe we will read out to Prof. The first one is from Boy Juzi. So maybe his question is, macam mana military robot pandai tembak? So maybe he is interested to know, yeah, Prof. Maybe you can have a few sharing session on this, Prof.
Yeah. Military robot pandai tembak. Okay. So kalau military robot, you see there are many military robot lah. Kalau yang pasal tembak ni, it's very interesting. You see biasanya manusia, if you bagi gun kan, dia tengok, dia tembak kan. Military robot also sama. Military robot is a robot that has a gun. But what is important here is that it is very tricky because the robot has to identify who dia patut tembak. Kalau manusia kita boleh tahu kan. Like contoh lah, I bagi satu contoh. You have a robot and then you tell the robot, okay robot, saya bagi kau gun. Okay, you tembak. Robot tu kata, okay, I tembak. Kata, siapa-siapa yang limpas sini, jalan, follow. Siapa-siapa yang pass by ya, you tembak. Kan, betul? You bagi tahulah. Sebab ini kawasan larangan. Tak ada orang boleh. Tapi kalau satu budak kecil jalan, robot tu akan tembak juga tu. Sebab kadang-kadang robot ni tak tahu identify. Dia akan tembak juga. Sebab dia tak ada feeling kan. Dia tak kenal kan. Sebab you bagi arahan saja untuk tembak. Dia tembaklah. Siapa-siapa jalan limpas, tembak. Tapi teknologi sekarang sangat baik. Bila robot tu ada kamera, dia boleh detect siapa tu. Adakah dia musuh? Adakah dia budak kecil? Adakah dia orang biasa? Kalau musuh, dia akan check dengan dia punya database. Dia ada database tu, dia check. Oh, ini penjenayah. Okey, tembak. Dia tembaklah. Oh, ini orang biasa. Jangan tembak macam tu. Kalau you nak kan, you tengok movie Robocop. You tengok movie Robocop. Robocop punya movie kan, dia akan tunjuk macam mana kalau robot tu faham and robot tu tak faham. Yang robot jahat tu kan, dia tak faham tu mana betul, mana baik, mana tak baik. Dia tembak saja. Tapi kalau Robocop tu kan, dia faham. Dia boleh nampak. Dia ada emosi sikit. Itulah contohnya bagaimana robot boleh tembak lah. Senjata sama saja. Okay? Tapi intelligence tu yang penting. Dia akan ada kamera, ambil data, check dengan dia punya database, check dia manusia ke tidak, dia penjenayah ke tidak. Baru dia buat keputusan. Okay?
Thank you, Prof. Very interesting, ya. Okay. So we hope adik Boy Jatzi ni boleh nilai ya jawapan daripada penceramah ni. Okay. So next adalah Dr. Daripada Muhammad Aiman Zul Hakim. Okay. The question is, Prof, what thing robot cannot do? So that's maybe a question.
Very interesting question you ask. Because many people have fear. Correct? Many people in the world have fear, oh, I fear a robot will take over my job. Imagine I'm a lecturer. Robot can take over my job, correct? One day, maybe in the future, robot will sit here and talk to you like this. There are 3 things robot cannot do or robot don't have. Number 1, a robot got no feeling. Okay? Robot got no feeling. Okay? Kasih sayang lah, orang kata kasih sayang kan. Of course, dia cerita, the movie show lah, robot tu rasa sedih lah, ada air mata keluar lah. Itu semua cerita saja. Tapi robot biasanya tak ada feeling. You tak boleh program feeling tu maksimum macam manusia. Okay? Robot tak ada insting. Insting ni apa tau? Macam dia boleh agak-agak lah. Something not right lah dia kata. Kan? Macam kamu bawa kereta kan? Kamu bawa kereta, kamu say, hati saya ni macam tak sedap dia kan? Itu robot tak ada. Nombor 3, robot tak ada moral judgement. Yang tadi saya bagi tahu kan, yang tembak tu, robot tak ada moral judgement. Kalau you kata tembak, dia tembak. Dia tak akan kira tu budak kecil ke, orang besar ke, penjenayah ke. Moral judgement dia kurang. Dia terpulang kepada orang yang program tu lah. Tapi berapa banyak nak program? Betul tak? Kan? Tapi kalau manusia tak payah program, dia tahu. Kalau kamu nampak kucing, kamu tahulah kucing tu tak akan bunuh kamu kan? Betul tak? Kamu tak akan tembak kucing, betul tak? Kalau kamu nampak harimau, kamu lari kan? Macam tu. Robot tak ada insting, tak ada feeling, tak ada moral judgement. Nah, sebab tu banyak benda yang robot tak boleh buat. Contohnya robot tak boleh melukis. Macam Picasso ke kan? Lukisan lah, lukisan-lukisan. Robot tak boleh melukis macam manusia. Kreativiti dia lain. Dia teknikal. Dia boleh copy lah. Boleh copy, boleh print. Tapi tak boleh melukis. Kerja halus. Kan saya bagi tahu tadi kan, kenapa industri teknologi 5.0 tu, dia perlukan manusia bekerjasama dengan robot sebab certain benda yang customization, personalization, hanya manusia yang boleh buat. Jadi banyak benda yang dalam dunia ni hanya manusia yang boleh buat. Contohlah, nak repair robot tu, manusia yang kena repair. Robot tak boleh repair sendiri. Robot boleh buat robot lain. Tapi kalau robot yang buat tu rosak, siapa nak repair? Manusia yang kena repair. Betul tak? Orang kata, saya kerja kilang. Nanti lama-lama kilang semua ada robot. Jadi saya tak ada kerja lah. Bukan macam tu. Kamu kerja kilang, dulu pasang-pasang. Sekarang robot pasang. Jadi kamu tukang repair robot. Jadi kamulah kena tingkatkan kamu punya level. Kan? Jangan jadi operator pengeluaran dekat kilang. Jadi technical. Kamu belajar sikit STEM. Jadi kamu boleh baiki robot, boleh servis robot, boleh maintain robot. Kalau ada apa-apa kamu boleh adjust sini sana bersama robot. Kerja ada juga. Yang penting kita kena ada STEM dalam hidup kita. Okay?
Betul sangat-sangat Prof. Memang on the point lah Prof. Okay. So we proceed to the next question Prof. So again from Muhammad Aiman. Okay. Yang tadi tu apa perbezaan human dan robot Prof?
Perbezaan human dan robot.
Ya.
Banyak beza dia. Robot biasanya ada mechanical, dia punya tulang tu tulang besi lah. Okay. Dia punya otot tu motor, ada hidrolik tu pakai cairan kan, atau pneumatik pakai angin untuk gerak. Biasanya pakai motor. Okay. Kita ada mata, robot pakai kamera. Kita ada tenaga dalam badan kita, robot pakai bateri. Macam tu. Kita boleh gerak tangan. Robot pun boleh gerak dia punya tangan. Kalau dia ada tangan lah kan. Tapi dia pakai motor. So, human, manusia dan robot ni ada, boleh katakan kita boleh kaitkan lah. Tapi dia memang, ini adalah mesin, ini adalah manusia. Dia tak ada darah, tak ada apa-apa lah. Okay, itulah perbezaan. Robot ni biasanya kan, semua ni ada kaitan dengan teknologi. Semua ada kaitan dengan teknologi. Yang penting untuk robot adalah kita ada otak kan untuk berfikir, betul tak? Robot ada chip komputer. Lagi laju chip komputer tu, lagi hebatlah robot tu boleh berfikir macam manusia, macam saja tapi tak boleh jadi manusia. Okay, kita boleh ajarlah robot. Kita ada robot, tahu tak? Kita ada robot yang boleh main catur. Robot yang boleh main catur kan? IBM Blue tu kita panggil kan? Robot ni dia boleh kalahkan juara catur dunia. Tapi dia kalah juga dengan juara catur dunia juga. Okay? Kadang-kadang boleh menang, kadang-kadang boleh kalah. Tapi dia kena gunakan komputer yang sangat besar dan sangat berkuasa. Sebab tak ada komputer dalam dunia yang boleh kalahkan otak kita. Okay? Yang paling hebat sini. Sebab kita yang cipta robot. Betul tak? Kita paling hebat. So, beza manusia dengan robot ni memang sangat jauh berbeza lah. Satu mesin, satu ada kulit dan satu ada nyawa. Robot tak ada nyawa. Okay? Robot tak boleh mati. Okay? Kita boleh mati. Itu je.
Okay, Prof. Very interesting, ya, Prof. Okay, again, we will take another question, ya, Prof. From, again, Muhammad Aiman. Dia memang berminat lah dengan topik robot ni, Prof. So, kita akan bacakan lagi. Okay, apa akan jadi sekiranya robot akan buat semua benda dan manusia tidak boleh buat apa-apa? So, itu persoalan daripada Muhammad Aiman lah.
Betul, Aiman. Tadi saya dah bagi jawapan sedikit kan.
Yeah.
Robot tidak akan buat semua benda. Tak boleh buat semua benda. Okay? Robot ada dia punya limitasi dalam kehidupan seharian. Sebab keputusan paling akhir perlu dibuat oleh manusia. Sebab tu kita ada, bila seorang itu dia reka cipta robot kan, biasanya ada undang-undang robot. Robot kena ikut cakap. Robot yang beroperasi lah, katakan industri ke apa-apalah. Apa-apa robot, robot tidak boleh membahayakan nyawa seseorang. Dia tidak boleh membahayakan nyawa seseorang. Dan robot mesti patuh kepada arahan yang telah diberikan. So, siapa yang bagi arahan? Mungkin ada robot bos lah kan? Ada robot pekerja dan ada robot bos. So, robot bos boleh bagi arahan kepada robot pekerja. Tapi robot bos ni kena ikut cakap manusia. Jadi, robot boleh buat pekerja. So, kamu tengok kalau kita tengok sejarah robot kan, perkataan robot ni pun ialah perkataan yang datang daripada macam dia kata pekerja. Buruh kasar. Buruh lah. Robot ni perkataan dia buruh. Maksudnya robot ni akan sentiasa menurut perintah. Jadi semua kerja robot mungkin boleh buat, tapi bukan semua, tapi arahan daripada manusia. Kalau macam tu, banyak benda yang manusia kena buat. Yang kerja-kerja tu tak kenapa dia cipta robot masa dululah kat industri. Ada 3 reason je. Sebab dulu-dulu dia panggil 3D lah dia kata. Nombor 1, dirty. Kerja-kerja yang kotor lah, yang ada macam kerja yang ada kaitan dengan minyak-minyak hitam tu kan. Kerja-kerja industri yang sangat kotor lah. So, kenapa manusia nak pergi buat kerja-kerja kotor tu? So, dia cipta robot untuk buat kerja-kerja kotor. Okey. Lepas tu, kerja-kerja yang dull, yang boring. Itu je. Bayangkan kamu pergi kilang kerja. Angkat ni, taruh sini. Boring kan? Dull kan? Takkanlah 1 jam, 2 jam, 3 jam buat kerja tu je kan? Jadi dia cipta robot. Okey. Kamu buatlah. Robot boleh kerja 24 jam tanpa berhenti. Janji ada current. Buatlah. Yang ketiga tu dangerous. Kita ada robot. Tadi saya tunjuk satu robot tu yang dia kata bomb diffusing robot. Dia gunakan dalam perang lah. Katakan ada orang dah taruh bom dekat satu tempat lah. Takkanlah manusia, dulu-dulu manusia memang dia pakai pakaian tebal tu, dia pergi dekat tu, dia buka tu, dia check tu, apa bom. Lepas tu dia repair kan, meletup matilah dia. Betul tak? Sekarang tidak, kita hantar robot. Robot pergi buka, pergi check. Meletup, robot tak mati. Pasang balik. So, ini yang penting. Dia cipta robot ni sebab, kalau bahaya tu kita hantar robot. Dulu ada dulu yang masa ada tsunami tu kan. Lepas tu dekat Fukushima ada nuclear reactor yang meletup kan. Rosak tu. Manusia tak boleh masuk dalam sebab dia ada radiation yang sangat tinggi. Jadi dia hantar robot untuk pergi off. Pergi check. Robot masuk dalam. Manusia tak boleh pergi. Dangerous kan? So 3D lah. dirty, dull and dangerous. Ini sebab robot digunakan di industri. Okay.
Thank you very much, Prof. Ini kita tak akan dapat ilmu ni dari mana-mana ni, Prof. Okay, Prof, can we take another question from Iwagar Munyandi? Okay, the question is, Doctor, what is your opinion about integration of robotics or STEM programs in national curriculum for primary and secondary school students? Integration of robotics, yes.
Yeah, very interesting question. So it's very important to integrate, because when you teach science, people only see the basic. But when you teach a robot, people are actually learning the integration of science, the application of science. They value, because they can see things moving, they can do things, they can be involved, they can learn a lot of things, and that creates interest. Like nowadays, why people don't like science? Because for them, science is very boring. You talk about diet, you talk about this, you talk about that, you only talk in the book. People cannot see. But when you start to teach robot practically in the school, primary and secondary, the children, the students can see practically how robot is being applied in their lives. Because it's very, they can see it everywhere, and now they are learning it. Now this will create interest in them, especially in science. So if I want to promote STEM, the best way is that I integrate this robotic education in primary and secondary. Before people decide they want to go and become a science person or an arts person, they can actually have an exposure, because even though I take a job that is not related to science, but end of the day, I use science. I use science. I have to use a handphone, correct? Sometimes in the future, my car will be automatic car. My fridge will be automatic. My house will be automatic. Imagine I don't want science. I don't want to know anything about science. But how am I going to live in rumah kayu? I cannot live like that in the city, And now in the future, there's no money, People don't use money, all use card or use chip. But I need to expose them, make them see it in the school practically. So education about robot will really create interest in them. It's necessary and is the need of the time. That is my opinion.
Thank you very much, Prof. So I think we will take another last question, okay, from Miss Lily Kalila. Okay, adakah jika semua telah dirobotkan dalam bidang perindustrian, apakah kesan kepada peluang pekerjaan? So maybe Prof can share back again.
Saya dah cerita sedikit sebanyak tentang itu kan. Perindustrian memang akan dirobotkan. Okay, teknologi sedang maju sangat. Sebab kalau kita jadikan industri ini robot, banyak robot, dia akan memurahkan harga. Itu penting, harga murah. Kan? Sekarang kalau kamu pergi emporium, pergi supermarket beli barang mahal. Kalau kamu beli online murah. Sebab the storage place is automated. That's why it's make it very cheap. Okay, that's one of the reason lah. Another thing, lagi satu perkara adalah peluang pekerjaan akan tetap ada. Dia tidak akan hilang. Tapi mungkin dalam bidang yang berbeza. Sebelum ni, industri perlukan ramai buruh kasar. Tahu tak? Buruh kasar. Dia perlukan orang untuk buat kerja-kerja macam pasang ni, pasang tu. Dia perlukan ramai orang. Tapi robot boleh buat kerja tu dengan lebih cepat dan lebih efisien. Right? Sebab tu kalau kita pakai robot untuk buat kerja-kerja buruh kasar, dia akan jadi lebih murah. Okay? Itu satu sebab. Tapi kita tidak perlu jadi buruh kasar. Kita perlu jadi buruh mahir. Yang penting sekarang, jangan jadi buruh kasar, jadi buruh mahir. Buruh mahir ini adalah orang yang akan membantu robot membuat kerja. You still need operator, but operator ni akan bekerja bersama dengan robot. Buruh mahir, kita panggil. Dia buat satu benda yang robot tak boleh buat. Robot akan buat benda lain yang robot sahaja yang boleh buat dengan lebih bagus lah. Betul tak? So, bila dua-dua ni ada, jadi sekarang ilmu STEM ni akan meningkatkan ilmu tahap pemikiran pelajar-pelajar, okay, supaya mereka pada satu masa yang akan datang boleh bekerja di kilang-kilang sebagai kaki tangan yang mahir, bukan kaki tangan yang tidak mahir. Jadi buruh lah. Kita tidak perlu lagi jadi buruh. Kita jadi kaki tangan yang pekerja mahir. Okay? Sebab kita ada ilmu STEM. Itu yang penting. Jadi pekerjaan akan masih ada, tapi dalam bidang yang berlainan. Kita kena upskill lah, dia panggil upskill. Kita kena tingkatkan kita punya ilmu kan. Kita tak boleh belajar macam tu saja kan. Sebab tu sekarang kita ada STEM. Takkanlah Malaysia ni tak payah belajar pasal robot. Macam tu juga. Tak boleh kan. Teknologi akan datang ke Malaysia. Jadi nanti kalau sekarang kamu tak nak drive kereta kan. Nanti kalau tak nak cuci kain pakai washing machine kan. Nanti 5 tahun akan datang washing machine automatic. Kamu taruh kain jadi. Tapi kalau kamu tak tahu tekan-tekan tu macam mana? Tak boleh pakai washing machine juga kan. Nenek moyang akan meninggal dunia. Yang tinggal kita. Jadi kita kena mahir dalam teknikal. Kerja tu akan ada. Sebab kita perlukan kemahiran manusia untuk membuat keputusan dan buat kerja-kerja halus. Dan also membantu robot menjayakan tugasan itu. Itulah pekerjaan yang sangat penting sekarang dalam era zaman moden ini. Okay?
Thank you very much, Prof. I think we can wrap up the session today for the question and answer session. Thank you again, Prof, for the very informative, very wonderful topic today, ya, Prof. Memang sesuai lah dengan the current situation in Malaysia, ya. And for the audience today, we will share with you the link for the e-attendance and for the e-sigil in the chat box and also in the presentation later on. And you can scan your QR code and you can fill on the simple feedback questionnaire, and you will be given the e-certificate later on, yeah. So thank you again, Prof, for the amazing presentation today. And thank you also for all the audiences for your support and your questions during the interaction today. Yeah, we look forward for the next session for the STEM speaker series. It's a pleasure to have all of you with us today, especially Prof. And with this, we conclude the webinar for today. And thank you again, Prof. And thank you all. Thank you, Prof.